All right, so I thought that it would be worthwhile just saying some general words of introduction. We have, of course, mostly members of the Royal Society with us. And this is a talk which is done in association with the Academy of Sciences of South Africa. We have all of the details of this on our website, and we hope that you will also be interested to take a look at that. So we are presenting tonight a talk by Professor Innocent Pikirayi, and I will say a little more about that in a moment. But just to say that we are the oldest society, multidisciplinary society in South Africa. We are open to anyone who's interested in science, and there are many benefits to that. I'm not going to read out all of this for you, but we do invite top South African and international scientists to talk. Our members and fellows have access to our scientific journal, which is highly regarded. And we offer, of course, benefits through networks. So here is a list of new members. I'm certainly not going to read all of those out either, but I would like to say welcome to those new members. It is very exciting to have you all there. And I'm actually not going to say too much about the Academy tonight, but the Academy do often partner with us in these kind of activities, and I think that that's a very good thing. So have a look at our website, and please do encourage others who are not members, and yourselves, if you are not members, please do take a look and perhaps consider joining us. Okay, so let me stop there. There we go. All right, and let me just introduce our speaker very briefly this evening. I'm just trying to, there we go. Trying to do a lot of things all at once here. Professor Innocent Pikirayi is one of my long-standing colleagues, and I'm absolutely delighted that he's going to speak to us this evening. He is a professor at the University of Pretoria in the Department of Anthropology, Archaeology and Development Studies. He's also the Deputy Dean for Research and Postgraduate Studies and Ethics in the Faculty of Humanities. He's well known for his interest in Southern African history, and I have heard him speak many times on many different topics related to that. He speaks about colonization and colonialism, but also the impact of various historical events on how we have come to where we are now, and in particular, very long historical events around local communities who were in particular places around Southern Africa. Innocent and I share a homeland in Zimbabwe, and I have heard him speak about that often as well. Tonight, he is going to talk about aquatic ecology at Great Zimbabwe, and I am very much looking forward to hearing what he has to say about what looks like a fairly unusual title, but I am completely confident that he will entertain us and interest us, and that this is going to be a fascinating talk. So Innocent, thank you so much for being prepared to give this talk, and we are very much looking forward to what you're going to tell us. So thank you very much. Over to you.
Thank you so much, Professor Burton, for the kind introduction. And to those who are joining us, good evening, to you all. And thank you very much to the Society for the invitation to do this presentation. Professor Burton for approaching me, and your entire team for putting together in a seamless way. If I could start sharing my presentation with you. This is indeed a fairly, what I would call, strange topic as far as Great Zimbabwe is concerned. But it is something that is scoping in terms of what we intend to do. But, a conversation to begin with in terms of what is going on, in terms of research, at Great Zimbabwe. In fact, earlier this month, I shared versions of this presentation with the Integrated History and Future Peoples on Earth, or IHOPE, which was hosted by Uppsala University, and that was on the 5th of September. And what you will hear from me in this lecture is making references to us, or to a team as we, because we are a teamwork, working on Great Zimbabwe mainly from Southern Africa and in Europe, with whom I would like to acknowledge at this very stage, for the aspects of this work that is, really emerging. Just to give you a background in terms of what I'm talking about, Great Zimbabwe is actually a cluster of monumental structures that you find in Southern Africa, in South Central Zimbabwe Plateau, and it existed for much of the second millennium AD. And what you see here, if you look at your slide to the left, is what we call the Great Enclosure, which is really a classic picture for those who have never seen Great Zimbabwe, who have never been to Great Zimbabwe. This is largely a photo that is, replicated in so many ways with the conical tower inside. And then your slide to the right is part of the hill complex. And in between the two, you've got the hill, the Great Enclosure in the background. There are valley complexes. These are the much smaller monumental stone structures that you find all over a site that is more than 700 hectares in extent. Now, Great Zimbabwe is part of a civilization that created or generated a major empire in Southern Africa between the Zambezi and the Limpopo rivers. And it is counted as one of the major empires, in Africa. If you go to West Africa, you've got these familiar major empires or mega empires like the, Empire of Ghana in Songhai, Empire of Mali. If you go to Central Africa, you've got the Lubalunda, as well as the Kingdom of Congo. If you go to the Horn of Africa, you have got Axiom, and these are sort of developments around state formation and the expansion of states in the African continent of the last 3,000 years or so. Now, if you add ancient Egypt into that, you are actually extending the timeline back to 4,000, if not 5,000 years ago. Mega developments, within the African continent. Now, my lecture today is an outcome of ongoing research on Great Zimbabwe, but focusing on water, and how its residents exploited and conserved this resource. And this paper was actually published in 2016 in the journal Wires Water, a scoping paper in that regard, identifying, these features, the features that I'm showing here, as water storage facilities. Now, these are some of the features that you see at Great Zimbabwe, but for which no one actually pays attention to, because all those who go to Great Zimbabwe are attracted by the monumental stone-built environment. And it will be a waste of time to be seen to be walking in these marshes, of water, which seems to serve no purpose at all to the person that is looking at these features today. Since 2016, since we published the Wires Water, we've also submitted another paper to the journal Anthropocene, which I put here is under review, but I've just been informed that it has been accepted. The paper actually engages with, deeper with the darker pits and how these were used to store water, for the residents. So that is why we named it climate smart harvesting and storing of water, the legacy of the darker peace at Great Zimbabwe. It speaks to these, features here in a much more detailed way, and engages beyond the world of archaeology and history to see exactly how societies in the present can learn the lessons of Great Zimbabwe in terms of storing water, especially for a complex society and a civilization that one finds at Great Zimbabwe and in ancient times. So my presentation today, or this evening, goes beyond those pits by actually engaging the granite landscape that you find at Great Zimbabwe. And it also assesses the importance of the landscape in terms of water resources that you do find around Great Zimbabwe. And our argument in this particular presentation is that the location of Great Zimbabwe was actually influenced by its crystalline rock context and the water that came from that context. And it was crucially the water that came from that context that provided the impetus, or at least the lifeline that rested with Great Zimbabwe depended on. So put simply, in terms of this diagram, where I show you the slide to the left, the monumental structures on the hill overlooking the great enclosure, that granite is indeed a vital building material. It's a fact and it's known. It's a geological fact. It's a construction fact, in terms of engineering in the built environment. But if you look at the slide to the left, granite is also a water resource. And this is where we are coming to. Now, on this two-dimensional map, if you look at the drainage of Great Zimbabwe, it shows, or one can characterize it as a radial drainage pattern. A pattern that facilitates fast drainage because of the vertical exaggeration of the relief. It also allows for minimal storage because of the location, the hilly location of Great Zimbabwe. Now, in our view, these were actually the key challenges of Great Zimbabwe residents, which they understood and from which their engineering of the landscape, they tried to resolve. So our approach to understanding what they did is informed by these methods, 4 in all: landscape surveys, where we try to understand the hydrological context and water sources of Great Zimbabwe. Then the geoarchaeological surveys, where we try to understand the character of the granite landscape around Great Zimbabwe. And then the archaeological excavations that we did post-2016 and published in 2020, where we try to examine the settlements that are situated on the periphery of Great Zimbabwe. Now, we also did what is referred to as LiDAR scanning to understand the built environment, in relation to the water sources at Great Zimbabwe. In other words, we're looking at the relationship between the stone structures and the water resources, because there's a tendency to simply understand Great Zimbabwe in terms of its stone-built environment or stone-built architecture, and then people forget that beyond that there are other resources that are equally vital. In terms of community engagement, we did survey the territory around Great Zimbabwe to understand the nature of its water resources, as well as the settlements that existed beyond the clustered built environment, beyond the sort of the monumental stone places. And what we were actually doing, if we put it in anthropological terms, we were listening to the narratives, oral narratives on water as well as the landscape. In other words, the relationship between the water, and the landscape. We also did a geoarchaeological survey, to understand the soil properties or the soil profiles and the human modification of some of the soils that you find in and around Great Zimbabwe, because both tell a history in terms of the origins of the soils that you find in Great Zimbabwe and how the soils at Great Zimbabwe were modified by the human beings in the last 2,000 or so years. Now, our archaeological excavations were done to understand the nature of settlements on the periphery of the built environment, sort of the clustered monumental complexes that you find within the Great Enclosure, the Hill Complex, and other sites. And here I'm showing you a slide with both the University of Pretoria students as well as students from Great Zimbabwe University, which is located very close by. And the most expensive part of the research was doing the remote sensing through light detection and ranging, what we call LiDAR. And the idea here was to examine the surface and subsurface context of Great Zimbabwe, mapping archaeological features, mapping your water channels, your springs and wells, as well as the darker pits, some of which were not visible actually to the naked eye. So the ultimate objective here was to come up with both a hydrological and archaeological interpretation of Great Zimbabwe. Now, in terms of the results, this is what we came up with. A normal landscape survey where you walk up and down the landscape to understand what is going on and interviewing local communities. We came up with what we call hydronyms and toponyms. Hydronyms, just terms referring to bodies of water in indigenous contexts, and then toponyms are those topographic names and the way they were understood in indigenous also context. But all of them do attest to the importance of water, that both in the past and in the present. They also mention your springs, particularly their ownership, and some of these springs, especially those that are found around Great Zimbabwe, are actually owned by clans, and some of these clans actually do claim ownership, of Great Zimbabwe. So this claim of a particular water source and linked to Great Zimbabwe is something that one can refer to or allude to in terms of water management, and as well as the politics and heritage of water management. Now, in terms of landscape surveys, this is a continuation of the previous slide. We also find what I see as an intricate connection between water and rock, and there are indigenous terms to bare rock, the term maware, and then local community worldview, in terms of how they name springs and relate to springs. Now, all these water bodies that you see on the slides to your right, is water that is generated from within the granite landscapes. It's not direct rainfall water. It's something that is issuing out from the rocks. So there's a very strong connection between local communities, the worldview, and water. And water is something that they say comes from rocks. And here, by referring to these rocks in local names, in geological terms, or in ordinary English terms, we're talking about the granite. And I'll say something quite in a detailed way in terms of the granite. We know that water is a product of rain, and in this particular world of Great Zimbabwe, in Great Zimbabwe itself, we do have a combination of summer rain and winter drizzle, and winter drizzle is referred to as guti. and it feeds directly onto the rocks. And then it's very difficult to harvest unless you've got rock tanks within the granite rocks, but it goes down. That is why the local community worldview links water with the rocks and the birthplace or the origins of the water as the rocks. So it's a very important point coming out from our engagement with communities in terms of the relationship between water and rocks. Now, part of our methodology was also trying to understand the geomorphology of Great Zimbabwe in terms of how to simply do a characterization of what it is and its relationship to water. Now, the three pictures on this particular slide show you a schematic diagram of some of the terms that we use in describing the surface and part of the subsurface of the granite. Now, this slide on the bottom left, shows you the hill complex of Great Zimbabwe, and this is the site on top here. But what you see here is what is called a Welbeck copy, which is schematically represented here. This is really references to, in English, what they call this is the Welbeck, but there are other names in different languages. And in my home language, there's the name Owari, and in Nguni language, they use the word Dwala. And then I think it's Germanic and Afrikaans is Inselberg and Bonhart. Now, if you look at other smaller landforms or features or structures, geomorphological structures, there's references to castle copies, and then nubbins, which are smaller than castle copies. Now, all of these are represented in Great Zimbabwe, within and around Great Zimbabwe. So you've got your Welbeck copies here. You can see some of them in the background. You can see your castle copies. They are represented here. And then your nubbins, are represented here. Now, the difference between a Welbeck, a castle copy, and nubbin in geomorphological terms is simply, about scale. The smaller you go, the smaller the height, or as you from your outcrops to something slightly much higher, to 40 to 50 meters, to something even much higher, is what makes the difference between this nubbin, the castle copy, and the Welbeck. It's really simply a question of scale. While they may look disconnected, from one place to the other, in geological terms, or even in geophysical terms or geomorphological terms, they are really part and parcel of the same thing. So while these formations appear as individual structures, they are actually interlinked below through a process that is referred to in geomorphological terms as H-planation. I don't have to bother you with some of these local names in terms of what they are. I've just explained them in simple terms. So there is a connection between all these structures, and this is very important in understanding what happened below, the sort of the valley of Great Zimbabwe. So if one looks at, let me go back slightly, this particular feature, this particular picture here, where you've got hills on either side, there is a plain here. So you're looking at this hill, for example, and this hill, and then the area in between here characterized by proper soil development and scree slope, that is withered rock from these hills and from these nubbins. This is where you find most of Great Zimbabwe. So Great Zimbabwe is lying on an area that is etched, or that is a result of a process that we call H-planation. Right, flat areas of soil where bedrock is undergone a lot of changing, alteration, as well as subsurface withering. Now, studies around the formation of these are fairly recent, of the last 20 or so years. That's when we started knowing what H-planation is. And in some areas where this takes place, some areas become very marshy because of the way soil is being formed. You see localized soil developments due to the decomposition of the rock, as well as the process of soil formation, and the soil or the grains from the rock mixing themselves with vegetable material, altering what we call the upper horizons, in terms of the soil profile. This to me is quite important, in the sense that what you see here at Great Zimbabwe is a process of explanation taking place between the hills, be they castle copies, be they Welbeck copies, and be they Nubins or Nabins. So these are the areas of considerable soil developments. And some of you might wonder, why am I interested in this particular sort of trajectory? Well, as an archaeologist, one of the courses that I took, at Uppsala in the 1990s was, the development of soils around the world, and I'm still part of that. An archaeologist must also understand pedology in order to understand stratigraphy. So this is what is happening. Beyond stratigraphy, there is a lot of what is happening in the soils, and for Great Zimbabwe, this is what we are beginning to see. And then the next question is, beyond these soils, what is then happening? What happens in the ground of Great Zimbabwe? I mean, over and above the soil that we see on the surface and subsurface. So we then need to understand what we call the hard rocks, or the basement rocks, or rocks of the basement complexes. And put simply, these are the granites, your basalts, your gneisses, that are formed from a few tens of meters below the surface to tens of kilometers deep below surface. But I'll not pretend that I'll be going more than a kilometer below the surface at all. I'm interested maybe in the 10 to 20 meters that form the subsurface of Great Zimbabwe. The fact is, these are the dominant rocks of the Zimbabwe Plateau. Now, believe you me, this is part of Zimbabwe, as well as part of South Africa. So the majority of the rocks that you find in Zimbabwe, especially in central Zimbabwe, are the rocks that we call the Zimbabwe Craton. And the equivalent of that craton in South Africa, especially the region in between the Namakwa province, Natal, in geological terms, and Namibia, as well as Limpopo, going into Mozambique, is what is called the Cabo Craton. The rocks there, and that you find on the Zimbabwe Plateau, are almost the same. Very old rocks, arguably some of the oldest rocks in the world, but perhaps not as old as the rocks that you find in the Canadian shielding, in North America. So that is what we have here. Now, Great Zimbabwe is here, is marked red here. This is where Great Zimbabwe is, and it's geologically it's interfacing the craton, and what is extruding from the craton are some of the rock complexes that are part and parcel of Zimbabwe's sort of gold belt. Throughout here, these deep brown soils are part of or rocks are part of the gold belt, and there's a small gold belt that passes through Great Zimbabwe. That's the subject of another day. What I'll talk about very briefly now is what happens within these basement rocks, especially their profile, the studies of which have taken place in the last 20 to 30 years ago. So put simply, in terms of their profile, what is talking about unconsolidated rocks or material that is sitting on a bedrock, a hard bedrock or a decomposing bedrock, which they call regolith. And this bedrock can be found up to several meters thick, or up to tens of meters in the subsurface. Now, again, put simply, the more you go down, in terms of the profile, the less fractured, these rocks are. So you get less and less fracture as one goes, down, deeper into the profile. Now, if you look at this diagram, this simplified diagram, which I borrowed from, a geological society engineering group, as well as Migno in 2010, and the other diagram to your right by Walter and others in 2018. Now, again, what people have been doing in the last 20 to 30 years is understanding, the profile of the basement rocks, the hard rocks. So it is actually an ongoing study from a geological point of view, but which is hardly informed or hardly engaged with the archaeology, because archaeology deals with, profiles of the surface and hardly with anything that goes below. So to simplify these two profiles, what you see here is soil, which is then translating further down into rock, from regolith further up to bedrock, and then from saprolite, that means in terms of withering, to fractured rocks, and then less and less of the fractured rocks, the fresh rocks that you see here. Now, in terms of water moving down into or towards the bed, the hard rock, you can actually look at that in terms of, high permeability in the surface, in the upper surfaces, that means in the regolith, and less permeability in the regolith. So these areas are considered as highly porous, and as you go down, they become less and less porous because the fractures, as you reach bedrock or the hard rock, are becoming less and less. So this is the principle in which granite has to be understood. And crucially, in between the hard rock and the withered rock, there's an area that stores the water. And this is quite crucial as far as Great Zimbabwe and other similar contexts are important. So we need to understand those areas in terms of, porosity and permeability, in terms of water. Again, studies of the last 20 to 10 to 20 years in terms of how rich, how potentially rich these areas can be in terms of their water holding capacities. Are they good aquifers? Are they bad aquifers? Where do you get water within the context of, such rocks? What happens, when you want to find a lot of water in that rocks? Where do you find less water in such, in such rocks? Now, in general, when you look at such rocks, because of their medium to low, permeability, it is generally regarded that, granite aquifers or basement complex aquifers have modest water resources, and if you compare them to, let's say, limestone landscapes, and volcanic landscapes, which compare, which have more and more water, one cannot regard them as, useful aquifers, right? But people look at permeability of the granite and say, look, because they are generally low aquifers, that is conditioned by them having a low permeability. And, for them to have high permeability or to make good aquifers, they must be highly fractured. And for them to be highly fractured, it means that they have to be highly withered. Now, I mean, this is a standard geological, geomorphological sort of fact. And we know in tropical Africa, this is what happens. So some crystalline rocks have exceptionally high water flows. And in fact, in parts of Africa, this is actually contributing a lot towards the water supply of fairly large settlements. And this is a study done by French scholars such as Lacazette and then de Wandel in the last 6 to 12 years. And then they try to compare that with what is happening in sub-Saharan Africa, a region that is water scarce, where it is known that groundwater from such context is very critical. Because it's such resource is critical, it has to be made accessible. And if one manages to exploit such water resource, it can make a difference. And all you need in terms of water harvesting, they say, from the points of exit from an aquifer is just simply by digging a well, or simply sinking a bore in a most appropriate location, particularly in the lower slopes of let's say a Welbeck copy or a Castle copy or even a Nabin. Now, let me go to the LiDAR scans before I come back to the profiles and develop an argument as a way of concluding my presentation. Now, the LiDAR scan that we did was to see and map subsurface features around Great Zimbabwe, features that may not be visible to the naked eye. And we successfully did so by flying a small plane over Great Zimbabwe and taking note of all these stream channel networks. I can claim that the only part of a stream you see at Great Zimbabwe is one that starts from here to a big river to the north, and another one that starts from here to another big river to the southeast. Now, all of this stream network that you see here is not visible to the eye. All this network here, it is a result of the LiDAR, the scanning that we did. Now, some of these features here in deep blue and light blue and white, some are visible to the naked eye, but some are actually not because of subsequent soil development. But LiDAR does take you further into the subsurface. It was able to reveal some of these shallow ones and semi-shallow ones, and as well as even some of these deep ones. If you go to Great Zimbabwe, you don't see this one anymore. You don't see some of this anymore. It's through LiDAR that we're able to see that. So we mapped their elevation. The LiDAR was able to map their depth and even their volume in terms of water content, just to give an idea as to how much water could have been stored in these facilities. So what we concluded from that was that, following our revelation the revelation of the streams by the LiDAR, that some of these pits actually lie in position that maximize the collection of subsurface runoff. And then they retain water in the vicinity of the ancient settlement. So from a mapping point of view, one can actually say these pits were simply water collection points, given the granite location, given the location of Great Zimbabwe, largely on an ash plain, and the rapid water runoff. So one can say you can use these pits as collection points. But you then need to look at the profile itself, the soil profile, which we did by digging the side of some of these pits, as well as some of the gullies that you find at Great Zimbabwe. From the top, from the surface, right down to almost to the lower levels of the regolith. This is something between 3 to 4 meters, and it's simply going further down. And then we concluded that the darker pits were also dug, to tap into the aquifer. So they were not just water collection points, for the water that is flowing from the sides of the settlements into the edge plain and further away. But, during certain times, they had to deepen these features to get water from below. In other words, they were actually going through this context here towards the fractured zones to get the water that they would need, at Great Zimbabwe. So here are a couple of discussion points that I want to run past you before I look at a global context. And these are serious knowledge claims, which I invite people to challenge during the discussion. The first point, I think, is more than a fact that what you see at Great Zimbabwe is is a site that, is on a granite outcrop, which is an edge plane, which was formed through a process of edge planation. And then with the water coming from the sides, from the hills all around it, it percolates into the plain, and then it re-emerges further down through springs, and some of it accumulating in swamps, and some of it actually being trapped into the darker pits. Then another point, which has not been mentioned by anyone, but for which we make a knowledge claim here, is that Great Zimbabwe lies on an aquifer. And I want to argue that it is, in geomorphological terms, both a confined, and unconfined aquifer. But we don't know how big the size of that aquifer is. But what we know that can give us a clue is that some springs have got high discharge rate within Great Zimbabwe, while others have modest, to low rates of discharge, and some have completely dried up. And I think all this may be a factor of the rainfall coming in a particular season or a cycle, or simply, some prolonged dry periods. Now, we've done soil profile development in terms of what is going on in Great Zimbabwe, and what we seem to see is that there are some soils that have been deeply disturbed, that show what is called anthropogenic, influence. These soils should be expected, are associated with sort of the local archaeological context that we find in Great Zimbabwe. These are the soils that we rush to, when we try to excavate and find out exactly, the cultural, sort of context of Great Zimbabwe. But beyond that, beyond these anthropogenic soils, there are soils like these, the reddish orange coarse-grained medium soils, that these ones here, that we've never been looking at before, that are crucial to us understanding Great Zimbabwe. These, in my view, are aquiferous in nature. They yield, they contain, and they convey groundwater, and it is the water that the residents at Great Zimbabwe actually used. Now, another point that contextualizes these particular findings is the recent studies on crystalline basement aquifers in both tropical and subtropical regions of the world, from the 1990s, which really focus on how much water can be obtained when someone sinks a borehole, on a particular, granite topography. And we know that, the residents of Great Zimbabwe did sink their darker pits on very strategic location, and not very close to the edges of the granite, especially where the granite gets, into the subsurface. But then it begs the question: how did Great Zimbabwe residents identify fractured zones and those zones that yielded maximum amounts of water? So here, what we need, is an application of traditional mapping techniques. It could be dowsing, and it's still known to be working. And other surface observations like geophysical auscultation, in terms of trying to find out where water on the ground or under the subsurface can be found. Now, that said, let me divert your attention a little bit in terms of what is happening the world over. And let me start by highlighting the current global water outlook and crisis as discussed in the World Economic Forum, where we need to highlight that the world is already experiencing a serious water crisis. Increases in water stress, reduced river flows, springs, reservoir depletion, all of these are being experienced in every part of the world, and they are a threat to settlement growth, a threat to urban growth. What they are pointing out to is that water is more than just a climate issue. It can trigger trouble, conflicts. It can force people to move from one place to the other. It impacts on several things, including the ecosystems and the economy. Now, I'm fascinated by this development here, or by this image, or what is currently experienced in Europe. The Rhine and the Danube rivers, these are the key routes in terms of trade in Europe, both Eastern and Western, and the low water levels that these water courses are experiencing. What you see in terms of boats being forced to carry less of the goods, from one city to the other, is something that affects the supply chain and how it is managed. Now, try to link that with what I'm trying to say as far as Great Zimbabwe is concerned, and then perhaps you'll be able to internalize where we are going with this. The question is, what then are the sort of the water scenarios, for Great Zimbabwe? First and foremost is in a region that is water scarce. As I've shown you from its catchment, from its drainage pattern, it is very limited catchment. It can only get that water from within the granite context. So its water needs certainly must have been constrained as the settlement grew, because water was central to its economy, for its political stability, and for the broader environment, the ecosystem. And it is not spurious to claim that in the past, Great Zimbabwe must have experienced droughts and climate change that we know, at least from history. There are several droughts that have been recorded since the 1940s. We know droughts since the middle of the 18th century. One of my students has actually worked on this. Then the building of reservoirs around Great Zimbabwe is something that points to human responses to those water needs, especially during times of scarcity. So the point here is that, when one looks at the granite and then one looks at the water, people may not see a relationship, but the relationship is that the granite was as important to the residents, because it was the trigger of what we see as the reservoirs on the other end. In other words, with what was produced from the granite or from within the granite, the reservoirs are the effect of that. So then the question is, was Great Zimbabwe ever confronted by a water crisis? This is something that I don't have answers to, right now. But when I look at these darker pits, and also when I look at the granites, I tend to think that this was probably more and more likely to have happened in the past. But this is at the moment, speculative. So in terms of reflection on the water ecology and ancient societies, and ancient complex societies in Luxembourg, there are a number of points that we are trying to, to develop as part of a conversation with the global world. First, the insights that one can gain, for better understanding and responses to, contemporary climate change or crisis. I would like to see Great Zimbabwe as responding to that, or at least as speaking to that in terms of what was happening, around it. The second point is how we should use the past to understand contemporary crisis in urbanization. Great Zimbabwe was an urban center. It was a city, one of the largest cities in sub-Saharan Africa in the second millennium AD. How did it respond? It responded to that crisis. I think the building of those reservoirs is a massive response. If you cross the Atlantic and go to the Maya world, this is also what was happening within some of the Maya cities, that there was considerable hydrological engineering to tap the water that was coming from the limestone context into some of the cities that you find now within a world that looks like a jungle, but really the Maya were not living in a jungle, but really in a landscape that they managed to exploit and to change quite radically. And then how should we understand decline or collapse of complex societies? Again, for Great Zimbabwe, this is something that is a challenge, but it is something that I'm delving into. It is something that I'm using water, for example, as a way of understanding what would happen, to complex societies such as the one living in Great Zimbabwe. We tend to use resilience theory to say Great Zimbabwe lasted as long as it did. Resilience in this way can be used as an escape route to say the society was still there, it never ended. But here we are talking about societies that really faced a crisis situation, but that went to a great scale or to a great extent in trying to ameliorate the potential danger in having no water around them. So these are some of the questions that I posed, and not just for discussion, but as a way of taking this project forward. So let me stop there and give the audience a chance to to engage. So thank you, Chair, and thank you all for the opportunity to listen to these ideas. And as I said earlier on, they are just the beginning of a long conversation, which I don't know what direction is likely to take in the very end. But my appreciation to you all.
Well, thank you very much, in a sense, for a very nice talk. The floor is open for questions. Are there any questions? Otherwise, I will kick off. You were mentioning that LiDAR technique. Just out of curiosity, how does that work? How do you get subsurface water data from a measurement like that? What do you exactly measure?
Now, LiDAR is simply a mapping technique that tries to, it's just like an X-ray. It's in fact, okay, it falls into that spectrum that, some of the things that we don't see by the naked eye, LiDAR tries to reveal, by way of, sort of digital imagery, and then one has to do a process that we call stripping. In other words, it's multi-layered digital data that looks at something that you see from the visual, from the naked eye, into something that you see beyond the naked eye. And sometimes it can go down even more than a couple of meters into the subsurface. That's when you see things like those features, the darker pits, emerging, because the soil has covered them up, but the LiDAR is able to see these different responses in terms of, let's say, the what is it called, magnetometry and other issues coming up, and so it tells you a story.
And do you use a laser as your primary signal?
Yes, the plane uses a laser, and the laser is constantly laid to and fro into the ground, and then it produces an image, and then that image has to be interpreted by way of stripping, the composite image. In other words, beyond the composite image that you get, there are several layers that you need to remove to see exactly what lies underneath.
Okay.
Yeah.
Thank you. Ruben, please unmute yourself.
Can you hear me?
Yes.
Yes.
Okay.
Loud and clear.
Yes. Thank you, Vincent, for the very nice talk. So my question is also on the LiDAR maps. Maybe I may have missed it. How many of the streams that you showed are still alive? And if not, do we know when some of them may have stopped to have lots of water, or do they come alive, for example, if there's a flood or something like that?
Yeah, there are two major streams that flow from Great Zimbabwe or past Great Zimbabwe. One flows to the north, and we always think that its source is from the bottom of the hill complex. But when you employ LiDAR, you see that it is part of that drainage mesh that comes from the hills to the south of Great Zimbabwe. Then there's another stream that flows past the hill, not the hill complex, but the Great Enclosure. But I think its source is from a flay in the valley settlements. Now, this stream, we can actually see it because it lies within the gorge. But further up, when you do the ranking or the order of the streams that are part of that, in other words, when you analyze the drainage pattern, you see more from the LiDAR than by the naked eye. So basically two. And you likely see water flowing during very good rainfall seasons.
Okay, thank you very much.
It's a pleasure.
Thank you. Are there any further questions? Well, if not, then I would once more like to thank you. Very, very interesting talk. For those of you who have been here very often, you know that we have a webinar every month. Next month we will skip, and the reason is that in October there will be a Nobel Symposium in Stellenbosch, and around that there will be webinars that will be broadcasted, not via the Royal Society, but we will advertise it on our website when the details become available. But we decided to skip that month then for our normal webinar. So the next one will be in November. And with that, thank you very much for attending.
Bert,
yes.
There's one question in the chat.
Oh, yeah.
Okay.
Innocent can answer that.
Yes, definitely.
That's in the chat, right?
Yes.
Okay. Right. Let me have a look at that. Say, could you please reflect on the role of local and regional droughts and its impact on water provision from subsurface aquifers in and around Great Zimbabwe? I think what I can say here is that to understand the role of the local and regional droughts as far as Great Zimbabwe is concerned, I think one also needs to look at the localized context, and in this particular case, the crystalline context is very important. Great Zimbabwe almost lies on the very edge of the basement rocks, and I think that location, vis-a-vis, let's say, a context that is maybe about 50 kilometers to the southeast, or even more, let's say we're talking about 100 kilometers, where you you will have actually left the basement complexes. I think the droughts in those particular areas are more likely to be severe because the soils and the subsurface context are different. And remember too, when we are talking about Great Zimbabwe, we do have these winter rains that help feed the crystalline context. So I wouldn't want to generalize on the regional droughts in as far as Great Zimbabwe is concerned, but look at the local context in terms of what is happening there too. Then you also said a related question is whether recurrent droughts could have had impact on the populations at Great Zimbabwe, and perhaps even its eventual reduction in size. I want to try to lend myself to that theory. There is some credence to that, but it must be supported by solid data. And this is why I'm coming up with looking at the context that goes on, that goes beyond the pits into the crystalline context as well, to say to what extent are droughts a localized phenomenon, given not just the geomorphology, but also the geology. So this will be like trying to offer site or area specific answers to what is possibly a regional, what could possibly be a regional problem. We know for sure that in the 1940s, particularly 1947, and also during the 1990s, there was this, the region experienced a severe drought, and that impacted the entire southeast. And in that case, your suggestion becomes valid. But there are some people who didn't experience a drought, or at least didn't experience water shortages, even in those drought contexts. And I want to think that Great Zimbabwe could have had exploited areas like this, contexts like this, to ameliorate potential crisis.
All right, thank you very much. I don't see any further questions, no hands raised, nothing in the chat. So then with that, I would like to thank you for the talk, and the audience for being here. And I wish you a very good evening.
Thank you so much. Bye-bye.
Thank you, Prof.